All right, folks, it's 3:30, and I see we've got a number of folks who've hopped on now. So I think we'll probably go ahead and begin the Electricity 101 webinar. Eric, if you don't mind making the PowerPoint, is it full screen for everybody? Okay. Well, I'll go ahead and begin. My name is Andrew Bateman. I'm the Deputy Executive Director here at ORS, and this afternoon, it's my pleasure to at least do the beginning of the Electricity 101 webinar. I may refer to it otherwise as E101. And the purpose of this webinar really is to take folks, other state agencies that are participating in powerSC who may not otherwise be really familiar with some of the key terms and ideas that really form a running theme of electricity generation in South Carolina, really the nation, but for powerSC purposes in South Carolina. And we hope to have a discussion and really go over some of the basics with y'all. The governor in his Executive Order 2023-18 tasked a number of agencies to form powerSC. We went over that in the August 24th meeting, and I know y'all are aware, but in order really to elevate the conversation and really work together in an effective fashion to find solutions to some of the energy challenges, I think it would be well worth our time to get together and go through some of the basics. So that's really what today is about. We're going to have this E101 seminar. It's not going to touch on everything. It's just going to touch on some of the basics, introduce these other state agencies, y'all, to what some of the basic terms, some of the basic ideas. And to the extent you have questions about E101 materials, don't hesitate to put that question in the Q&A. As the presentation is going on, there will also be a brief Q&A session at the end of the webinar. If one of the state agencies has a question more broadly related to powerSC, we're absolutely happy to answer that. But because that question and answer may end up going a bit beyond the scope of the E101 webinar, we just request that you send that question just to me or someone of Commerce offline, and be happy to talk with you about that question offline. So without further delay, I'll jump in. We've got the first slide up already. This is just sort of an outline of the agenda. Right there, we've got an outline of the agenda. I'm going to go over introductions. That's going to be really as it relates to who ORS is and who the Energy Office is. I think many of you already know who those two agencies are, but to the extent we're working with an agency that's really less familiar with ORS or the Energy Office, this will be sort of a good primer on who we are and what we do. And then I'm gonna go over some key terms. Really, I've got a couple of links that will refer you, really great resources to go over probably any term you could think of as it relates to energy generation. I'm only gonna go over specifically 5 just in the interest of time. And then I'm gonna kick it off to the director of the South Carolina Energy Office, Director Bazemore. And she's gonna go through a few slides dealing with electricity fundamentals, generation, distribution, and transmission, and power providers. And then she's going to kick it off to Robert Lawyer with ORS, and he's going to go through federal and state regulation, South Carolina challenges and opportunities, and then he'll probably kick it back to me for a brief Q&A. Again, as we're going through this, to the extent you've got questions related to the E101 presentation, don't hesitate to populate them in the Q&A thing in the bottom right-hand screen, and we'll work to answer those. If you've got questions more broadly related to powerSC, we're again more than happy to answer those. Let's just we'll handle those offline, and that way we can have a more in-depth conversation on that. Eric, if you don't mind jumping the next slide, thank you. So this slide sort of outlines who ORS is and who the Energy Office is. So many of you have worked with the Office of Regulatory Staff in the past, and you know exactly who we are. But for those who don't, Act 175, passed in 2004, split what was otherwise known as the public staff off from the Public Service Commission and created the Office of Regulatory Staff. And really from that time in 2004 up until about 2015, 2016, ORS almost exclusively worked with regulated utilities in South Carolina before the Public Service Commission. And it's for that reason that the Office of Regulatory Staff has such a really a deep well of knowledge about the energy challenges that face South Carolina and that some of these utilities are working through right now. Now, for those who know ORS, know that in the 2015-2016 timeframe, the General Assembly actually took the Energy Office and took it from the Budget and Control Board and gave it to the South Carolina Office of Regulatory Staff, and we've been blessed to work with some really great folks from the Energy Office since that time. And I'll give you a brief primer of who they are, but in a second I'll kick it over to Sarah Bazemore, the Director of the Energy Office, in just a second. You may also know that another non-regulatory side of the Office of Regulatory Staff that we've gotten more recently is the Broadband Office. And they've done some really great work working with internet service providers in the state, making sure that areas which were otherwise unserved or underserved when it came to broadband infrastructure are now getting the infrastructure necessary to really put high-speed internet throughout the state. So the South Carolina Office of Regulatory Staff, it's got a statutory mission to represent the public interest. The public interest is defined as the concerns of the using and consuming public with respect to public utility services, regardless of the class of customer, and preservation of continued investment in and maintenance of utility facilities so as to provide reliable and high quality utility services. The Energy Office, as Sarah will probably go through a bit more in a second, actually is a statutorily non-regulatory body, and they've got actually a slightly different mission. In 1992, the Energy Office was created. South Carolina created the Energy Office and established as its state energy policy to have a comprehensive state energy plan that maximizes to the extent practical environmental quality and energy conservation and efficiency and minimizes the cost of energy throughout the state. And as you may recall from our August 24th meeting, there's actually a specific section in Governor McMaster's executive order which calls out both the Energy Office and ORS as it relates to the state energy plan. I believe this is section 1A2 if you've got the executive order in front of you. Eric, if you don't mind moving on to the next slide. Perfect. So this is a slide, this deals with key terms and resources. And if you click on either one of those links, they'll take you to really a dictionary of energy terms. It will have probably every energy term that you could think of that you wanted to go through. Today, just in the interest of time, I'm really only going to focus on 5 terms. Some of these terms may be expounded upon a bit by Sarah or Robert as they come up. But these are terms that I think we would all probably benefit if we had at least a base knowledge of what these meant as we discuss the challenges that South Carolina energy infrastructure is facing, and we really look for solutions to present to the General Assembly and the Governor in an effort to fulfill really the Executive Order 2023-18. So the first key term that I'm going to go through is baseload capacity. Some of you may know what that is. Others probably have heard that term. But the definition of baseload capacity is generating equipment operating to serve customer load 24 hours per day. So when an entity talks about a baseload generating facility, it's a facility which that utility has the ability to call on 24 hours a day, 7 days a week, and get energy generation from that facility. So you may think of a nuclear facility. A nuclear energy generating plant would likely be considered a baseload facility by an electric utility. There's a term that sort of goes along with baseload generation pretty frequently, and that term is dispatchability. When someone talks about a generation facility being dispatchable, it means that that utility has the ability to call on that facility to get power whenever they need it. It doesn't mean that it's going to be on 24 hours a day, 7 days a week. There, of course, will be times where a generation facility would be taken offline for maintenance or for repairs. But aside from those, if a utility is dispatchable, it's got the ability for the, or if a generation source, excuse me, is dispatchable, the utility has the ability to go in and get power from that generation source 24 hours a day, 7 days a week. This may be contrasted with other generation sources, maybe such as solar. You know, when the sun is shining on a solar panel, it absolutely is generating electricity. But when the sun is not shining on that solar panel, midnight, 1 a.m., 2 a.m., no electricity is being generated. And for that reason, that solar panel would not be called dispatchable, because there's literal physical limitations that prevent that generation facility from actually generating energy 24 hours a day, 7 days a week. The next definition that I'll go through is capacity. This is another term which you've probably heard, and you may have sort of an informal understanding of what it means. But capacity equals the maximum output that a generator can supply to system load. And for a little bit of context, when you think about capacity and you think about you know, a base load plant, like a nuclear generating plant may have the capacity of 1,100 megawatts. So that's, you know, just to give you a frame of reference for when folks are talking about capacity and they're talking about megawatts, for someone who's maybe not, you know, really seasoned in this industry, you may not have a good frame of reference for what is a lot of megawatts, what is not a lot of megawatts. So think about a nuclear generating facility as having, you know, about 1,100 megawatts, maybe 1,050 megawatts, something like that. You may have a natural gas plant which generates somewhere on the order of 700 megawatts, something like that. All right. Here's another term which you've probably heard, and I would imagine that you've got at least an informal understanding of, but it is still good for this conversation to hear a technical definition, and this is cooperative electric utility. An electric utility legally established to be owned by and operated for the benefit of those using its service. And this is really contrasted, at least for purposes of our conversation, from an investor-owned utility. You know a number of electric co-ops in South Carolina. There are 4 investor-owned utilities in South Carolina. There's Duke Energy Progress, Duke Energy Carolinas, Dominion Energy South Carolina, and a real small investor-owned utility up in Union, South Carolina called Lockhart. Another term which you know you have probably heard before, and you may have at least an informal understanding of, is demand-side management. Demand-side management is a utility action that reduces or curtails end-use equipment or processes. You know, as we have these conversations and we look at the governor's executive order, and over the next you know, near future, we work towards finding solutions for some of the energy generation and transmission challenges in South Carolina. There are really, I think, probably a lot of tools in the toolbox that we're going to need to use. An obvious one, and one that is critical, is just more generation. But another tool in the toolbox may be something like demand-side management, where we work together, and perhaps there are creative ways in which rates can be implemented, which can help alleviate some of the burden of generation strain. And for that reason, I highlighted demand-side management. Another term is grid. I think we've all probably heard the term grid, and again, we at least have an informal understanding of what the grid is. But technically, the definition is a system of synchronized power providers and consumers connected by transmission and distribution lines and operated by one or more control centers. So the grid is the entire tentacles that go out throughout the state of transmission, distribution, substation, operation centers, generation, those nuclear facilities, the solar generation. All of these things work together to form an extremely complex thing called the grid. And that grid must operate really in perfect harmony in order for it to continue working the way in which the population and industry needs and expects it to work. Let's see, and with that, Eric, if you don't mind switching to the next slide, I'm going to kick it off to Sarah Bazemore, the director of the Energy Office, and she'll run through a few slides, and I'll see you back at the end. Thank you.
Thank you, Andrew. Good afternoon, everybody. I appreciate y'all joining us on a Friday afternoon. In true energy office fashion, this part is really a primer, like Andrew started with, on electricity or energy 101. And so it's our educational outreach, and is really beneficial to me, and I hope will be helpful to y'all in helping us all make sure we're using the same terminology and not using words that have possibly two meanings. Like we mentioned earlier today at the EV meeting, charging can refer to charging with putting the electric charge in, or how much you're charging cost-wise for the charge. So let's clear some of these things up. First, I want to distinguish between electricity, power, and energy. And sometimes they're used interchangeably, but they really have different meanings. Electricity is the flow of electrons in a circuit. It's the movement of a charge. And electricity is electrical energy. Volts are typically the metric used for measuring energy. It's the measure of that force making that electricity move. So the rate of the voltage is the power. So that takes us to power. So electricity is that flow, and then the power is the rate at which that movement is happening. The power being used at any time, in one time, is the wattage. So that's where we get watts. So we've got electricity in volts. That's the movement. We've got power. That's the rate of that movement measured in watts. Now, power and not energy is measured in watts, and it's the rate at any second being used. Electric power typically, however, is measured in larger units of watts, known as kilowatts or megawatts. And not to offend anyone's math skills, but 1,000 watts is a kilowatt. And a kilowatt is the basic unit of electrical demand. And that'll matter in a minute when I expand on this. 1,000 kilowatts is 1 megawatt. Also, it's 1 million watts, right? 1 megawatt measures power on a large scale and is the standard term of measurement for bulk electricity. So 1,000 megawatts then becomes a gigawatt. Let me put this in terms that everybody can relate to. 100-watt light bulb. You think of getting a 100-watt light bulb. 1 megawatt can power 10,000 of those 100-watt bulbs for 1 hour. So now we've added another component. We've added in the time that power is used, and that's where we get energy. The usage of that power over a period of time is energy. Now, it's important to remember you don't generate, or you do generate power, but you use energy. You generate power, you use energy. You can't generate energy. You have to convert energy from one form to another. Electrical energy is often converted to heat, light, mechanical energy. Now, you've probably heard of storage. Power cannot be stored or saved. So remember, power is generated and it's consumed at the same time that it's generated. Energy can be stored, but it's not easy. It's not easy to store electrical energy or electricity. So to store electricity, the electrical energy often has to be converted to another form like heat or light. Energy, however, is measured in watts per hour because it's that usage of power over time. So electricity in volts, power in watts, kilowatts, megawatts. Energy, you're going to hear of in kilowatt hours or megawatt hours. And a megawatt hour represents how much electricity is delivered through that system in an hour. So on your electric bill, 1 unit is 1 kilowatt hour. So that's 1 kilowatt of power consumed or used in 1 hour. If you consume 1 kilowatt of power in 1 hour, you're charged for 1 unit of electricity. Taking that a step further, 1,000 units is 1 megawatt hour. So assume a house consumes 100 units in 1 month. 1 megawatt hour can power 10 homes for 1 month. We can put that a little bit more into perspective on some things that we handle daily. Eric, if you'll slip to the next slide. This shows kind of a contrast of what 1 megawatt hour versus 1 kilowatt hour can do. Let's look at how powering the average American home. For 1 megawatt hour, you can power it for 1.2 months. But on 1 kilowatt hour, you can only power it for 50 minutes. Driving an EV, the big talk these days. With 1 megawatt hour, you could drive that EV for over 3,000 miles. But on 1 kilowatt hour, you could only go about 3.6 miles. And since it's the afternoon and we're probably hungry for snacks, let's look at how many slices of bread you can toast. On 1 megawatt hour, you can toast 89,000 slices of bread. But using 1 kilowatt hour, you could only toast about 89. Still be enough for me. Next slide, please. Now that power is generated from different types of energy, and energy comes from a variety of fuel types. Fossil fuels that you'll hear from time to time are coal, natural gas, oil, petroleum. Another one that's prevalent in South Carolina especially is nuclear. Other types of fuel or energy come from solar, wind, hydropower or water, biomass or geothermal. There are some others, but these are some of the big players. And the ones like solar and wind and hydropower, those are often referred to as renewables. Now, to be resilient, a mix of energy types is important. So let's look at South Carolina's energy generation mix. You'll switch to the next slide. Remember, this is based on the sources from which the energy is generated, or the power is generated. Power in South Carolina, as you can see, is generated from a lot of different fuels. Nuclear represents about 38%. Natural gas, about 32% combined. Coal, about 27%. And solar, hydro, and biomass and pump storage, the rest. If you'll flip to the next one, that power is generated on either a utility scale or a small scale. That was just representing utility scale. In South Carolina, our utility scale generators are known as investor-owned utilities, most of them. Our IOUs are Duke Energy, which is actually 2 different entities, Duke Energy Carolinas and Duke Energy Progress, Dominion Energy South Carolina, and Lockhart Power. We also have a state-owned utility that generates power, and that's Santee Cooper. Some of our other electric utilities operate as power distributors, but not generators. And those are going to be our electric cooperatives and our municipal electric utilities. To get power from where it is generated to the customer and where it is used, everyone plays a role in that. And so this graph here on the right shows that municipalities service about 6% of customers in South Carolina. And 31% is the electric cooperatives. So you see everybody plays a role and everybody has a big part in getting these this power to the customers. Next slide. So let's look at the power from generation to consumption. Starting on the power plant side, it's generated at power plants for the most part. Again, this is real high level, just starting with the basics on energy. Once it's generated, it travels along high voltage transmission lines. It may reach a utility and then is stepped down to distribution lines that can then deliver that power to the customers where it is consumed. All of that and more is part of the grid. The grid supplies the electricity or the power to users and consumers in homes, in commercial buildings, in industrial operations. And it's a massive interconnected network of electrical equipment, transformers, substations, and it creates and supplies this electricity to end consumers. It's also called sometimes the electric grid, the electrical grid, the electricity grid, the power grid. For our purposes, we're going to call it the grid. Now, a given building has a meter, and you see that where it says your meter in the middle, or a little to the side of the middle, that monitors how much energy the building consumes. And this meter acts as an imaginary dividing line between the supply side and the demand side. Now, the demand side is also often referred to as behind the meter. So you'll hear front of the meter and behind the meter. Behind the meter energy management includes ways that a customer can control or use energy. So let's look at some of those ways that energy consumption can be controlled behind the meter. Next slide, please. One of them is energy efficiency. Energy efficiency is the permanent reduction of electrical demand through the installation of efficient systems, improvements, or upgrades in equipment, devices, or the building. And it reduces energy consumption. Energy efficiency programs are often offered by utilities to customers. And this helps to incentivize reduction of energy consumption, making your home more efficient in their use of energy. It increases efficiency and therefore decreases the overall demand for electricity. Sometimes these are in the form of rebate programs to customers. Another form of behind the meter is demand response. Demand response programs are implemented again to decrease customer demand during times of very high system demand or emergencies. So if you think everybody in the morning is getting ready and making their coffee and using all kinds of electricity, there's a peak, as Andrew was talking about. And then everyone goes to their office or wherever they're working. And then towards the end of the day, everybody goes home and again adjusts their thermostat. And there's another peak in demand, increasing demand. So demand response programs pay customers to reduce their energy load during times of grid stress or high energy demand. Sometimes the demand for energy can outpace the grid's ability to supply it. And so, as Andrew was saying, instead of producing more energy, the grid can offset the imbalance by reducing the amount of electricity being consumed during those high demand times. And so it serves to stabilize the grid by ensuring that supply and demand stay balanced. Demand response is a change in electricity consumption by consumers, especially larger consumers like commercial and industrial businesses. And it helps to keep that balance on the supply and demand. The next one is our distributed energy resources, or DERs. DERs are small-scale generators of energy resources, usually located on or near the site where they're being used. Some examples might be rooftop solar or battery or thermal storage. These can be aggregated to provide the power that's necessary to help meet a customer's regular demand for electricity, otherwise that it would be pulling from the grid. In recent years, there's been amazing technological, economic, and regulatory changes in the industry, in the energy industry, and it's made it feasible for grid operators to integrate these DERs into their electric grids. The rapid expansion of DERs is transforming not only the way electricity is generated, but also how it's delivered and consumed. One of the things we're seeing with electric vehicles, as I have it on there, and was talked about again today, is this option of increasing technology in vehicle to grid, or V2G technology, where the vehicle can even, at times of need, put power back on the grid rather than just thinking of the charging and charging and charging. in need, it can almost act as a generator and put power back on the grid. So those are some of the ways. That's just the basics. Obviously, it gets way more detailed, but that's the non-regulatory side. So the regulatory side, I'll kick it over to my counterpart, Robert Lawyer, and let him tell you a little bit about the landscape and how the regulations surrounding energy work in South Carolina.
Hello, everybody. Robert Lawyer here with the Office of Regulatory Staff. My position here is the Director of Energy, and I've been here for approximately almost 17 years. What I'd like to talk to you about today is a little bit of the regulation side of the house, as well as some challenges and opportunities for South Carolina. This first slide here deals with the Federal Energy Regulatory Commission, also known as FERC. We live in a land of acronyms here, so you will hear more of those, but FERC is the first one. So who regulates who and who regulates what? The FERC is an independent agency that regulates the interstate transmission of electricity, natural gas, and oil. They also review proposals to build liquefied LNG terminals. LNG is liquefied natural gas, and interstate natural gas pipelines, as well as licensing certain hydroelectric power projects. There's some things that they do not do. For instance, they do not regulate nuclear power plants. That would be a whole nother entity that we're not going to talk about today. So, excuse me. The Energy Policy Act of 2005 did give FERC some additional responsibilities, and one of those was to protect the reliability of the system through mandatory reliability standards. Next slide, please. So speaking of reliability, we come to NERC. This would be the North American Electric Reliability Corporation. They are international. They are not for profit. Their mission is to assure the effective and efficient reduction of risks to the reliability and security of the grid. They develop and enforce reliability standards, which all our utilities that we regulate here at ORS adhere to. And overall, they just monitor the bulk power electric system. They also educate and train and certify certain industry personnel. And their area of responsibility spans the entire United States, Canada, as well as the northern portion of Baja California, Mexico. And they are directly under the oversight of the FERC, which was the previous slide, as well as authorities in Canada. Their jurisdiction includes users, owners, and operators of the bulk power system, which is approximately about 400 million people. So it's quite a bit. And NERC is also, you've got the main, I guess, the mothership of NERC, but it's also split up into 6 other regions across North America. In our particular South Carolina, we're part of the CERC, another acronym for I think it stands for the Southeast Reliability Corporation. Next slide, please. Okay, here's pretty much ORS's bread and butter. We talked about FERC and NERC, and to be honest with you, ORS, we're not too involved with those entities on a regular basis, but we do monitor both, especially, well, I shouldn't say especially, but on the FERC side, whatever happens there, most likely is to trickle down to the state level for implementation, which in turn will somehow, some way, in some form have an effect on rates that you and I both pay. For, excuse me, I lost my place. Public Service Commission, NERC, we don't really deal with them too much either unless something goes wrong, because they're a reliability corporation, right? So to give you an example of some of those things that go wrong, for instance, last Christmas, I'm sure you all are familiar with Winter Storm Elliott that came through. There were some blackouts in the area, as well as North Carolina. And several years back, there was also a Winter Storm Uri, which mainly affected Texas. But they all dealt with reliability and resiliency and eventually trickled down to the RS as we were tasked to do several reports dealing with both of those storms. So back to the Public Service Commission. This is who we deal with pretty much on a daily basis. ORS by statute is an automatic party to every case that may come before them. They essentially function as a court for cases involving the utilities we regulate, as well as other regulated companies such as motor carriers of household goods, water, wastewater companies, just to name a few. And when I say a court, it's almost just like that. They're a quasi-judicial body. You have the case or an application or a filing of some sort by a utility that we regulate, mainly wanting adjustments in rates or something to that effect. We will be an automatic party, as I stated. You'll have the filing. ORS will issue discovery upon these companies. We will do a review of their books and records. We will submit testimony. The company will supply rebuttal. We'll do surrebuttal. Then we'll actually have a hearing. And then the 7-member commission will hear the whole case and ultimately deliver a ruling or an order. Some cases that come before the commission that we're involved with are mainly cost related or cost recovery related, I should say, for either expenses they have incurred for fuel, such as the fuel adjustment clause, general rate cases, which would involve your basic facility charges and overall volumetric charges for whatever kilowatt hours you use, integrated resource planning, various programs that they might want approval for, such as solar net metering, EV programs, and the DSMEE programs that Sarah mentioned earlier. But one thing on this slide, that I want to bring to your attention is that Facility Siting Environmental Protection Act, because I think it really jives with this this group. If I could just read for you a second, or let me tell you what it is first. Whenever say somebody wants to build a solar farm and it's over a certain megawatt threshold, or there's transmission lines that might be involved that are over a certain voltage, they have to come in under the Siting Act. It is triggered where they will need to get Public Service Commission authority, or the commission will issue them a certificate of environmental compatibility and public convenience and necessity, or a CEP-CN. And there's also a couple other state agencies that are involved in those proceedings, such as DNR, Parks and Rec, as well as DHEC, on top of ORS. They will supply some input to those cases as well. But to bring it home to the executive order, if you take a look at action or initiative, and you don't have to look now, but whenever you get a chance, it's number 1A7, and I'm just going to read you a part of it. To analyze any state licensing or permitting processes governing the construction, operation, or expansion of energy-related infrastructure and facilities, and identify any opportunities to reform or improve the same. So I think this is a place where ORS is in a position, as this group goes forward, we are available, and we can offer our experience in that area, as we've been involved in several of those cases before our Public Service Commission. Next slide, please. All right, I understand that some of you in this group may have seen these two next slides before, but wanted to reiterate the importance of them. As you see on the slide, there's kind of 4 main buckets of concerns from ORS perspectives over the short term and long term. The need for diverse generation being the first one. We've seen both of these, the load growth due to economic development over the years and population increase. There doesn't seem to be any end in sight with those. We've had BMW, Volvo, several companies come in over the years. You've heard of Scout coming. All this is going to require more generation to meet this demand. And as the population, of course, increases year after year. Diverse electric generation is necessary to minimize price volatility and enhance reliability. But at the same time, we're trying to add or meet new demand with diverse generation. You also have planned retirements that are in the pipeline for several utilities, mainly coal plants. So that generation is going to have to be replaced on top of the new generation for the new demand from the economic growth and population growth. Natural gas capacity. Yes, we do have some. We don't have enough. We're going to need more. And that's very crucial in getting that into the Southeast. We're kind of on the end of the line, if you will, for gas. So we can get some more in South Carolina. That would be great. I'm sure you've heard of the Mountain Valley Pipeline. Hopefully that'll alleviate some of that challenge, but it certainly won't take care of it all. The Atlantic Coast Pipeline was in the works, but is no longer. So what's next? And that still poses a challenge to us. You heard Andrew earlier mention baseload generation. Baseload generation, it's there, yes, run 24/7, but it's there to meet minimal level of demand on an electrical grid over a span of time. And when I say minimal, I mean, we're at it now. That minimum is going to increase. Therefore, that baseload generation needs to increase. Transmission or the cost, land use, and infrastructure and regulation. I look at this bucket as kind of the challenges on top of those other challenges I mentioned to maintain reliability. Pipeline development. I mentioned two projects. One made it through, one didn't. They're very hard to get done. There's a lot of competing interests in that arena, and they're very costly. And that brings you to affordability, which ORS mainly deals with in our cases, because those costs, any cost to build or improve or replace or add to, those costs are going to be paid by ratepayers, you and me. Next slide, please. So the opportunities we have, you heard about the challenge, what opportunities? With those challenges come the opportunities. And these are some of the initial thoughts of ORS. You've got to take an all of the above approach. You cannot put all your eggs into one basket. Again, the retirements, we need to pace those with new development, so we're not shorting ourselves and leaving ourselves hanging with more blackouts of some sort or any other problems. The state energy plan has some recommendations in it. This is a plan that came out of Sarah's group several years ago. If anybody would like a copy of it, I'm sure we can get it to you if it's not on our website. We can leverage our existing South Carolina resources with existing rights of ways in the infrastructure we already had. Is it possible to build on it or improve on it? Strategic use of federal and state funding. I think everybody's probably aware of the IIJA, which is the Infrastructure Investment and Jobs Act, as well as the IRA, the Inflation Reduction Act. I'm not sure how much money South Carolina will get out of that, but it's definitely something we need to look at and use to our benefit while it's there. And then we need to communicate, coordinate, and collaborate, which is what this group is supposed to do. And I look forward to doing it with y'all in the future. Also, streamline processes to support expansion. Are there any regulatory processes that need to be changed, added, amended, or completely done away with? Something to think about. And then cost-effective energy efficiency, which Sarah hit on a little bit ago as well. There are programs in place. Is there more we can do there? Is there more we can do to alleviate or mitigate the challenges that were on the previous slide? So back to the communicate and collaborate and coordinate mantra. I think that's what we all need to do to come up with those solutions. Andrew, that's all I have. If I'll turn it back over to you.
Thank you, Robert. Thank you, Sarah. I appreciate it. We're going to have a real brief Q&A And then a slide after this one actually has the contact information for Robert, Sarah, and myself, to the extent you don't already have it. But before we jump there, I actually now have the corrected data for that South Carolina Energy Utility Landscape slide. Eric, if you don't mind jumping back to that, I think it was probably slide 7 or 8, and we'll run through just what the, right there. So the legend is actually incorrect, and we're gonna correct it. And when we work with Commerce to post this presentation, everyone who's viewing this will have the corrected slide. But just so you know, right now, 56% is actually IOUs, not municipalities. Municipalities is the lighter green, the 6%. Santee Cooper is the blue, the 7%, and the electric co-ops is that yellow, the 31%. I think I got that right. Santee 7, Munis 6, IOUs 56, co-ops 31. Yep. So we'll fix that when we put the final presentation out for post. But I wanted, while we had that data to go ahead and correct, I wanted to go ahead and remedy that inadvertent error. Eric, if you don't mind jumping back to the final slide, it's got the contact information for Robert, Sarah, and myself. I see no questions in the Q&A. Again, don't hesitate to reach out afterwards if you've got a question more broadly related to powerSC. In the meantime, I hope that you learned a little bit about the electric generation industry and at least a base primer on some really important terms that we'll be using. I know I can speak for everyone here at ORS, and I think the Energy Office as well, that we really look forward to continuing to work with y'all over the near and long term as the executive order directs, to work towards finding solutions to the energy challenges that South Carolina and the nation are facing right now. So with that, I also recognize it's 4:17 on a Friday afternoon, and many of y'all are probably looking to start your weekend. So don't hesitate to reach out. Otherwise, I hope you all have a great rest of your Friday and a great weekend. And that's it from our side. Thanks, everybody.